A blessed day to all of us. We are the reporters of selection sort algorithm and linear regression algorithm.
So selection sort algorithm, it sorts an array by repeatedly finding the minimum element, considering ascending order from the sorted part and putting it at the beginning. So how selection algorithm works is that we're trying to find the minimum element or value in a list. And the first value or element of that list is considered as the minimum element, and then comparing it to the numbers to its right. And as soon as we came across an element or number value that is lower than the minimum element, that number is now considered as the minimum element, as the new minimum element, and so on and so forth. Selection sort algorithm of two subarrays in a given array. The first subarray, which is the sorted, and it can be found at the beginning. So as soon as we finish comparing each numbers, so we can now divide the list into two subarrays, which is the sorted, the first subarray, and the unsorted, the second subarray, that can be found after the sorted subarray.
Selection sort. Naiupat ka steps kung saan pag-perform sa selection sort. Step 1. Tanawa na tong unang element sa table. So kung ascending order ang buhaton, dapat ang unang element is the smallest element na makita sa table. For example, sa table, atong makita ang mga elements na 29, 72, 98, 13, 87, 66, 52, 51 ug 36. So atong makita ang 29 ang unang element sa table. So ang atong buhaton pangitaon nato ang smallest element sa table, which is ang 13. Step 2. Atong i-compare ang unang element ug ang atong giselect nga element, which is ang 29 ug ang 13 kung asa ang gamay nga element. Step 3. In every comparison, kung makita nato kung asa ang gamay sa element, ato silang iswap, which is ang may tabo, si 30 na ang unang element sa table o si 29 mabutang na sa ikapat nga table. Lastly, step 4. Balika ang parehas nga way nga naay element sa sunod nga posisyon sa list hangtod ang tibuok list maset.
Good day everyone, this is Marfi Siganob reporting about linear regression. Linear regression attempts to model the relationship between two variables by fitting a linear equation. There were two variables in linear regression, the independent variable and dependent variable. So, linear regression is used to estimate the relationship between two quantitative variables, which are independent or explanatory variable and dependent variable. But before we attempt to fit a linear model to observe data, we should first determine whether or not there is a relationship between the variables of interest. This does not necessarily imply that one variable causes the other, but that there is some significant association between the two variables. If there appears to be no association between the proposed explanatory and dependent variables, then fitting a linear regression model to the data probably will not provide a useful model. To further understand, here is an example. You are a social researcher interested in the relationship between income and happiness. You survey 500 people whose income range from 15,000 to 75,000 and ask them to rank their happiness on a scale from 1 to 10. Your independent variable, which is the income, and dependent variable, which is their scale of happiness, are both quantitative. So, you can do a regression analysis to see if there is a linear relationship between them.
Linear regression line has an equation of the form y equals b0 plus b1x. The slope of the line is b1. The intercept is b0. The independent variable is x. The dependent variable is y.
Independent and dependent variables. Independent variables is the variable that was being manipulated x, and dependent variable is the variable that shows the relationship either positive or negative relationship y. Read an example of positive relationship and negative relationship of a linear regression. My example of positive relationship: the study time and grades or GPA, whereas if your study time is plenty then your grades is better and vice versa. The negative relationship, time on mobile games and grades or GPA, whereas if your time on playing games is big or plenty then your grades will be lower and vice.
What is linear regression? Linear regression, from the word line, it is a regression that is shown using line on the graph. So in here we have two variables, the independent variable and the dependent variable. The independent variable is what we control or manipulate, and the dependent variable is the outcome, which is an independent variable is shown using x and the dependent variable is shown using y. In here, we have observations, and using these observations, we can draw the regression line. Here, the regression line. The two types of relationships, the positive relationship and negative relationship. For example, we are given that study time as for the independent variable and the GPA or grade for the dependent variable. This shows that as you study, time is larger, your grades is better. And in the time of playing mobile games, as an example of negative relationship, as your time on playing mobile games is greater, then your grades will suffer, which shows the negative relationship. The formula used in solving the positive relationship is estimated value of y is equal to b0 plus b1x. While on the negative relationship, the used formula is the estimated value of y is equal to b0 minus b1x. Let's solve an example. We are given the values of 1, 2, 3, 4, and 5 as the independent variable x, and 2, 4, 5, 4, and 5 as the dependent variable y. Next, we must put this in an observation into the graph. So 1 and 2 should put here, 2, 4, 3 and 5, 4 and 4, 5 and 4. After putting the observations, let's get the mean. The mean of x and the mean of y. So in solving the mean of x, we must use the formula summation of x over the number. So summation here is 1 plus 2 plus 3 plus 4 plus 5 is equal to 15 divided by 5 is equal to mean is equal to 3. So in here also the y, same with the x, it has the same formula, although let's use the y variable. So y mean is equal to the summation of y over the number. So 2 plus 4 plus 5 plus 4 plus 5 is equal to 20 divided by y mean 20 divided by 5 is equal to 4. So the reason why we get the mean of x and y is to be able to draw the point in which the linear regression or the line of regression should pass through. So in here we got the x as 3 and y as 4. So 3 and 4. So in here we put the observations of the given values, and in here we put the point in which the line of the regression should pass through. Here the coordinates of 3 and 4. Next, let's use the formula estimated value of y is equal to b0 plus b1x for this example and solve the y-intercept of the slope. So let's put the values that was given. x as 1, 2, 3, 4, and 5. Y is 2, 4, 5, 4, and 5. Let's get the mean, which is 3. X mean is equal to 3. Y mean is equal to 4. And next, we must get the x minus x mean. So x, which is 1, minus x mean is 3. So 1 minus 3 is equal to negative 2. And so on. Negative 2, negative 1, 0, 1, and 2. And the same with the x. Y minus the mean, which is 2 minus 4 is equal to negative 2. And so on. Negative 2, 0, 1, 0, and 1. Then let's square the value of this line or table. X minus x mean squared is equal to negative 2 squared is equal to 4, negative 1 squared is equal to 1, and so on. 0, 1, and 4. Then get the summation of x minus x mean squared. So in here, let us multiply the x minus x mean. Let's show this correctly. X minus x mean multiplied to y minus y mean. So 2 times 2 is equal to 4. Negative 1 times 0 is equal to 0, and so on. 0, 0, 0, and 2. Then get the summation. Next, we must solve the slope. In solving the slope, we must use the b1 is equal to the summation of x minus x mean multiplied to y minus y mean. So, we already get the value of the summation, which is here. So the summation is 6, and the other one is the summation of x minus x mean squared. So we already get the value of this. So here, b1 is equal to 6 divided by 10. b1 is equal to 0.6. This is the slope. So in here, we must solve the y-intercept using the value of the slope, which is the 0.6. So the formula for this is estimate of y is equal to b0 plus b1 times x. So we already have the value of estimated value of y and the value of x, and also the value of the slope. So here 4 is equal to b0 plus 1.8, which is the result of 0.6 times 3. Let's put negative 1.8, then crush out. Also here 1.8, then minus. So 2.2 is equal to b0, which is the y-intercept of the slope. So now we have the point in which the line should pass through and the y-intercept of the slope. So the value of 2.2 should be around here, which is if you use a roller and connect the 2 points here, connect the 2 points, we can draw the line of regression or the regression line. So let's go back to the values and let's put the estimated values. So the given values or the actual values are 1, 2, 2, 4, 3, 5, 4, 4, and 5, 5. So these are the actual values. So now that we have the line of regression or regression line, we can also put the estimated values. So the estimated values are 1 and around 2.8, 2 and 3.4, 3 and 4, 4 and around 4.6, 5 and 5.5, like that. So these are the estimated values. So in the step 12 is show if there was a relationship between the two variables using the actual and estimated values. use the formula r squared is equal to the summation of y estimated value of y minus y mean squared over the summation of y minus y mean squared. So in here, we must solve the y minus y mean of y squared. So let's first do the let's first get the values of this for us to be able to solve the formula. So let's put the value of x 1, 2, 3, 4, and 5, value of y 2, 4, 5, 4, and 5, and get the mean of the y, which is 4. Then in here, let's minus the y minus y mean. So 2 minus 4 is equal to negative 2, and so on. So 0, 1, 0, and 1. In here, we must square the value of this table. So 2 square, negative 2 squared is 4. So and so on, 0, 1, 0, and 1. Then get the summation. So the summation of this is 4 plus 1 plus 1 is equal to 6. So in here, to get the estimated value of the given observations, we must use the formula estimated value is equal to b0 plus b1 times x. So y is equal to, we already got the b0 in the earlier, which is 2.2. Oh, here 2.2, the y-intercept of the slope. So we also got the slope of the regression line, which is 0.6. Here the slope, and the x values are here. So 0.6 times 1 is equal to 0.6 plus 2.2 is equal to 2.8, and so on. 2.8, 3.4, 4, 4.6, and 5.2. Next, we must get the estimated value of y minus y mean. So 2.8 minus 4, so is equal to 1.2, and so on. Negative 0.6, 0, 0.6, and 1.2. So next is we must square the value of this table. So square of negative 1.2 is equal to 1.44, and so on. 0.36, 0.36, 1.44, and get the summation, which is equal to 3.6. Now we can use the this formula because we already got the summations. So r squared is equal to the summation of estimated value of y minus y mean squared over summation of y minus y mean squared. So 3.6 over here over 6. So 3.6 divided by 6 is equal to r is equal to 0.6, and the explanation to that result is this was a good result, as it shows that the independent variable has a relationship with the dependent variable. If you are questioning how can we determine if it has a relationship, there was a note. Note, as the result of r squared is closer to the value of 1, it shows it had a great relationship. And closer to 0 does not have a relationship. So the explanation of this is that if these values and these values are closer and we solve that, and the value we got in r squared is closer to 1. So for example, these values should be put this here, and 2.4 is here. Okay, 3.5, 4 and 4, and 5 and 5 here. So it shows that it has a relationship. As we can see, the value of this here are close to each other. So it shows that the value of the actual and estimated values are close enough to each other as it reaches 1. So if it reaches 0, for example, if the result of r squared is equal to 0, then probably the number are the actual values should be around here or here and here. Let's put this like this. So as we can see, it is more farther away than the estimated value. This shows that the two variables, the independent variables and the dependent variables, have no relationship at all. Example, let's say that study time here and this was GPA or grades. So as you have more study time, let's show this. If you have more study time, probably your grades are higher. So these two variables, the study time and the GPA, have a relationship. So let's put another example. Let's say that here, let's put that having mobile phone. So here, if you have more mobile phone or devices in your home, should be your GPA be higher or lower? For example, you have two cell phones or you have one cell phone and one laptop. So you have more devices. Should your grades be higher? So in that, the result of r squared would be probably 0 because it doesn't have really an explanatory relationship at all in the independent and the dependent variable. And that would be all. Thank you.